So let's get your test references out and we'll figure this one out. Do I have more than two elements here? Okay, so I must have some polyatomic ions. So here I'll look on the common ions list. Okay, and I'm going to try to find some of the stuff that's in here. Alright, let's see if I can maybe overlap it a little bit to find them. Probably the easiest way to do it. Alright, it's just asking for the name. Is that correct?
Yes.
Okay. Now, make some room. Well, the first part is this part right here. There's F-E-S-C-N. F-E-S-C-N. So that's ferrocyanate, isn't it? Okay. And now we're going to look for this one. Well, yeah, but look here. There's two of them. We got to figure out which one it is. Okay, well, hold on a minute. This is not that hard. How many of these things do I have? I have three of these, right? Okay, and each one of them has a 2 plus charge, correct? So 3 times 2 plus. Okay? And how many of these things do I have? 2 of them. Okay? So there's 2 times some number inside I need to find, and the whole thing has to have what kind of charge? Yeah, it has to be a 0, yeah. That same stuff, okay? So what number do we need to go there? 3 negative. So which one of these 2 is the one that I need? This one right here, the hexacyanoferrate 3. So the name of this then is hexacyanoferrate 3. Here we go. So yttrium is right here. And what charge does it have? 3. So we know we got to have a 3 plus here. Alright, and then what charge does fluorine have? 1 negative. Okay, so what numbers do I put in front to get a formula that comes out to have an overall charge of 0? A 1 and a 3. And that means I need to have a Y, and I don't need any subscript here because it's a 1. But on a fluorine I need how many? And we show 3 fluorines in a bond with subscripts like that. So there's, well, 1 times 3 plus yep. This is multiplication. This is multiplication, then add the 2 together. Okay. All right. Then sometimes you have to figure it out. Okay? The question will give you everything you need to figure it out. You just have to use the tools that you have at hand. Okay? Yes, Thomas? Sure. That's actually in your handout for the most part. Would it be better if I just showed you on here? Or would it be better if I drew it out? Okay. Huh? Yeah, give me a minute. Okay, alright. Alright, now, of course, uneven is not the only thing you got to know, but the only 2 uneven shapes that we've dealt with in here are a bent, which looks like this. Maybe I'll put an A here and a B here. Alright, there's an uneven shape. And then trigonal pyramidal is an uneven shape. Okay, so those are the only 2 uneven shapes that we deal with in here. There are 3 even shapes that we've dealt with in here. There's linear. Let's see, there's trigonal planar. Sure. And then, yes, there is indeed tetrahedral.
Tetrahedral has 3 D, right? Oh, I got 2 Tetrahedral representing 3D, right?
Well, they're all really 3D, but these are actually just flat.
Yeah,
right there.
Like the main one with the triangle. Is that the only one you draw triangles on?
Yeah. This can occur when you have a triple bond, or you can have, well, let's see, no. This can happen with triple bonds or 2 double bonds. In this class, with the stuff that we work with, that's probably the only case it would happen. It can actually happen in other cases, but you don't deal with those in a CP class. That's a good observation. Yes.
Okay. How do you determine what hydrogens belong in just a structural formula?
How do you what now?
Determine where hydrogens belong in.
Well, we kind of answered that already. Yeah, kind of. We said was in a skeletal formula, if the carbon is on the end of the structure over here, you know that every carbon has got to have 4 bonds overall. Well, this skeletal formula shows 1 bond on this carbon here on the end, which means it needs 3 more carbons. And this carbon has 2 bonds showing going to it, so this carbon has to have 2 hydrogens to finish up the number of valence electrons it wants to have.
So, like, how would you say it, like, if you add something to
I'd say it just like that.
the last, like...
In a skeletal formula, a carbon on the end needs 3 more hydrogens because it's only showing 1 bond. And a carbon in the middle of the chain would have to have 2 more hydrogens because it's showing 2 bonds on it. Of course, I could have something like this. Okay, and then this carbon only needs 1 hydrogen because it's showing 3 bonds on that carbon. Or if I had this, now that carbon's not going to have any more hydrogens on it because it already has 4 bonds. Usually in the middle of the chain it needs 2 because if it's in the middle of the chain and there's nothing else bonded showing as a bond on there, then it's got to have 2 more bonds. Okay? More questions? Yes, Aaron?
Okay. So when you name acid, number 41 it says, what is the name for the acid HI? The oxygen,
You want to know the name of that acid?
don't you like change it like hydrogen?
Yeah. Yeah. So this is the friendly acid. Okay. So you first name this like an ionic compound. Hydrogen. Iodide. Okay. So when we learn to name ionic compounds, we learn to name it like that. This is a binary acid. 2 elements, but not necessarily 2 atoms. That's what a binary compound is. This is a binary acid. So for a binary acid, you drop that part. Remember that was the joke about high school students aren't supposed to be drinking alcohol, so you don't want any gin. Okay? And then ide gets replaced with ic. These 2 parts are joined together. And then you're going to put the word acid on the end. So this becomes hydroiodic acid. Hydroiodic acid, yeah. That's how I would say it. Yeah, but I mean, you're not going to be asked for pronunciation on the test, so it doesn't really matter. What? Well, you might have to name compounds. That's one of the things that could be on the test. Okay, naming compounds was in the last unit, but we keep needing that, so I'm trying to re-emphasize that. Yeah.